Hello. Now let's solve this example. In this example, there is a point mass which is given here. This is a point mass, and the position vector of this point mass with respect to the origin, this is the origin, is given I cap plus 2j cap plus k cap. It's a vector. In terms of vector, it is given already. And this point mass is experiencing a force F, which is 2I cap plus 3j cap plus k cap, Newton obviously. That much force this point mass is experiencing. And we have to calculate the torque experienced by this point mass with respect to the axis. Okay. So if we need to calculate the torque experienced by this point mass with respect to this origin, we have the formula to calculate torque. That formula is R cross F. And we have actually 4 formulas. By solving this, we have 4 formulas basically. We can have R, F, sin theta n cap. This is also we can use. Or mod R, F perpendicular to R, n cap, or mod F, R perpendicular to F, n cap. So, to calculate the torque, I can use any one of that formula. But the thing is, to calculate the torque using these 3 formulas, I need to calculate the mod first, and then I need the angle or the n cap, basically. These 3 formulas, I will be calculating the magnitude separately and the direction separately. But if you see the question force and position vector itself is given in terms of I cap, j cap, k cap. So if it is given in terms of I cap, j cap, k cap, and if I went to calculate mod F and mod R, it will take time. So the thing is, I will not be using these 3 formulas. I will be directly solving the torque using the first one by the definition itself. Okay. So let's calculate that. The torque is R cross F. So let's put the value of R, which is I cap plus 2j cap plus k cap. And we'll take the cross product of this R with 2I cap, 3j cap plus k cap. So, if I take the cross product, 1 by 1 we'll be taking the cross product here, or we can use the matrix method. Okay, so let's use the matrix method. No, let's solve it 1 by 1 using the screw rule. So this is I, this is j, and this is k. So we'll take the cross product here with the first, obviously we have to follow the order. This quantity we have to multiply with all these 3 quantities 1 by 1. So it will be 2I cross I plus 3I cross j plus I cross k. Then we'll multiply this with all 3. 2 into 2 is 4. 4 j cross j plus 6 j cross I here plus 2 j cross k plus, now this one will be multiplying with all 3, 2 k cross I plus 3 k cross j plus k cross k. So now we have to simplify each and every one. So if you want to simplify it, the thing is I cross I, and if you see I cross I, j cross j, and the k cross a, k, they all become 0. Okay? Because the angle between I and I, j and k is 0. Now here I cross j, you see here. If you take the cross product of I with j, you are following the same direction of arrow, so you will be getting the positive value of k. So that will become 3 times of k cap. Then I cross k cap, you will be getting the j. But the thing is, you are following opposite to the arrow, the j will become negative. So this is minus j. Now this one, j cross I will give you k, but since you are following the opposite to the arrow, it will be minus. So j cross I is minus of 4 times k, because the 4 is there. This becomes 0. And this one, j cross k is I, and it will be positive. So positive 2 times of I. Now here, k cross I will be getting the j, and it's in the same direction, so 2 times of j. And the k cross j, you'll get I, but since it will be negative, so minus of 3I. So you have taken all 9 points into account. So let's combine similar values. So this is 2I and minus 3j, will be getting the minus of I cap, j and j, plus of j cap, and this one, minus of k cap. So the value of torque will be equals to minus I cap plus j cap minus of k cap. Okay. And obviously the unit, if you see, you are multiplying the R with F, so it will be Newton into meter unit. Okay, so that's how we calculate the torque here. If you want to calculate the direction of this torque, all you have to do, take the unit vector along the direction of tau. So direction of torque will be along tau unit vector, which will be nothing but vector of torque divided by magnitude of the torque. You can get the direction also here by using this formula. Okay, so that's how we calculate the torque in case when the forces and the position vector are provided to you in terms of I cap, j cap, and k cap. Okay, thank you.